Hello everyone. Today we are going to see the next part of this chapter. The name is Introduction to Documentation of Systems, and we had completed till Check Your Progress 1. Now we will start from types of documentation. Let's see. Any software project is associated with a large number of documents depending on the complexity of the project. Documentation that are associated with system development has a number of requirements. They are used by different types of audience in different ways as follows. They act as a means of communication between the members of development team. Documents are used by maintenance engineer. Documents are used by the user for operation of the software. Documents are used by systems administrator to administer the system. System Requirement Specification. System Requirement Specification is a set of complete and precisely stated properties, along with the constraints of the system that the software must satisfy. A well-designed software requirement specification establishes boundaries and solutions of system to develop useful software. All tasks, however minute, should not be underestimated and must form part of the documentation. Requirements of SRS. The SRS should specify only the external system behavior and not the internal details. It also specifies any constraints imposed on implementation. A goods a good SRS is flexible to change and acts as a reference tool for system developer, administrator and maintainer. Characteristics of a System Requirement Specification (SRS). All the requirements must be stated unambiguously. unambiguously. Every requirement stated has only one interpretation. Every characteristic of the final product must be described using a single and unique term. It would be complete. The definition should include all functions and constraints intended by the system user. In addition to requirements of the system as specified by the user, it must conform to any standard that applies to it. The requirement should be realistic and achievable. With current technology, there is no point in specifying requirements which are unrealizable using existing hardware and software technology. It may be acceptable to anticipate some hardware developments, but developments in software technology are much less predictable. It must be verifiable and consistent. The requirement should be shown to be consistent and verifiable. The requirements are verified by system tester during system testing. So all the requirements stated must be verifiable to know conformity to the requirements. No requirement should conflict with any other requirement. It should be modifiable. The structure and style of the SRS are such that any necessary changes to the requirements can be made easily, completely, and consistently. It should be traceable to other requirements and related documents. The origin of each requirement must be clear. The SRS should facilitate the referencing of each requirement for future development or enhancement of documentation. Each requirement must refer to its source in previous documents. SRS should not only addresses the explicit requirement but also implicit requirements that may come up during the maintenance phase of the software. It must be usable during operation and maintenance phase. The SRS must address the needs of the operation and maintenance phase, including the eventual replacement of the software. Rules for specifying software requirements. The following are the rules for specifying software requirements. Apply and use an industry standard to ensure that standard formats are used to describe the requirements. Completeness and consistency between various documents must be ensured. Use standard models to specify functional relationships, data flow between the systems and subsystems, and data structure to express complete requirements. Limit the structure of paragraphs to a list of individual sentences to increase the tractability and modifiability of each requirement and to increase the ability to check for completeness. It helps in modifying the document when required. Phrase each sentence to a simple sentence. This is to increase the verifiability of each requirement stated in the document. Structure of a typical SRS document. Introduction. System reference and business objectives of the document. Goals and objectives of the software describing it in the context of the computer based system. The scope of the document. Informative description about the system. Information flow representation. Information content and structure representation. Description of subsystems and system interface. A detailed description of the problems that the software must solve. Details of information flow, content, and structure are documented. Hardware, software, and user interfaces are described for external system. Functional description of the system. Functional description restrictions slash limitations, performance requirements, design constraints, um, diagrams to represent the overall structure of the software graphically. Test and validation criteria. Performance limitation, if any. Expected software response. It is essential that the time and attention be given to this section. Glossary definitions of all technical or software specific terms used in the document. Bibliography list and reference of all documents that relate to the software. Appendix supplementary information to the specification. System design specification. The system design specification or software design specification is referred to as a primary audience, the system implementer or coder. It is also an important source of information for the system verification and testing. The system design specification gives a complete understanding of the details of each component of the system and its associated algorithms, etc. The system design specification documents all as to how the requirements of the system are to be implemented. It consists of the final steps of describing the system in detail before the coding starts. The system design specification is developed in a two-stage process. In the first step, design specification generally describes the overall architecture of the system at a high level. The second step provides the technical details of low-level design which will guide the implementer. It describes exactly what the software must perform to meet the requirements of the system. Tools for describing design. Various tools are used to describe the higher level and lower level aspects of system design. The following are some of the tools that can be used in the system design specification to describe various aspects of the design. Number 1. Data dictionary. Definition of all of the data and control elements used in the software product or subsystem. Complete definition of each data item and its synonyms are included in the data dictionary. A data dictionary may consist of description of data elements and definitions of tables. Description of data element. Name and aliases of data item. Its formal name. Uses. Which processes or modules use the data item. How and when the data item is used. Format. Standard format for representing the data item. Additional information such as default values, initial values, limitations, and constraints that are associated with the data elements. Table definitions, table name and aliases, table owner or database name, key order for all the table's possible keys including primary key and foreign keys, information about indexes that exist on the table. Database schema. Database schema is a graphical representation of the whole database. Data retrieval is made possible by connecting various tables through keys. Schema can be viewed as a logical unit for programmers' point of view. ER model. Entity relationship model is database analysis and design tool. It lists real life application entities and defines the relationship between real life entities that are to be mapped to database. ER model forms basis for database design. Security model. This database security model associates users, groups of users or applications with database access rights. Trade-off matrix, a matrix that is used to describe decision criteria and relative importance of each decision criterion. This allows comparison of each alternative in a quantifiable term. Decision table. A decision table shows the way the system handles input conditions and subsequent actions on the event. A decision table is composed of rows and columns separated into four separate quadrants. Input conditions, condition alternatives, actions, subsequent action entries. Timing diagram describes the timing relationships among various functions and behaviors of each component. They are used to explore the behaviors of one or more objects throughout a given period of time. The diagram is specifically useful to describe logic circuits. State machine diagram. State machine diagrams are good at exploring the details, transactions between states as the result of events. A state machine diagram is shown in figure 4.2. Here is the state machine diagram with start active model state 1, login state 2, then comes log out again back to state 1. Then comes object interaction diagram. It illustrates the interaction between various objects of an object oriented system. Um, Please refer to figure 4.3. The diagram consists of directed lines between clients and servers. Each box contains the name of the object. This diagram also shows conditions for messages to be sent to other objects. The vertical distance is used to show the life of an object. Here comes message 1, message 2, return, return, object 1, object 2, object 3, an object interaction diagram. Okay. Then comes a flow chart shows the flow of processing control as the program executes. Please refer to figure 4.4. Start, input, processing, output, and flowchart. Now comes inheritance diagram. It is a design diagram work product that primarily documents the inheritance, relationships between classes and interfaces. In object-oriented modeling, the standard notation consists of one box for each class. The boxes are arranged in a hierarchical tree according to the inheritance characteristics. Each class box includes the class name, its attributes, and its operations. Figure 4.5 shows a typical inheritance diagram. Object, account, client. Under account comes SB account, current account. Under client comes corporate or individual. So it is typical inheritance diagram. Aggregation diagram. The ER model cannot express relationships among relationships. An aggregation diagram shows relationship among objects when a class is found as a collection of other classes. It is called an aggregation relationship between these classes. Each module will be represented by its name. The relationship will be indicated by a directed line from container to container. The directed line is labeled with the cardinality of the relationship it describes. Has a relationship. Figure 4.6 shows an aggregate between two classes. Circle has a shape, a circle and shape. Here you can see aggregation 4.6. Structured chart. How long is this unit? Mm, oh, we have to. Okay, only 2 pages, 2 to 3 pages. Yes. Where were we? Here, structure chart. A structure chart is a tree of subroutines in a program. Refer to figure 4.7. It indicates the interconnections among the subroutines. The subroutine should be labeled with the same name used in the pseudocode. So here is a structures chart. System under which comes is subsystem A, subsystem B. Under subsystem A comes program A1, program A2, program A3, and under subsystem B comes program B1, program B2. Pseudocode. Pseudocode is a kind of structured English of describing algorithms in an easily readable and modular form. It allows the designer to focus on the logic of the algorithm without being distracted by details of language syntax in which the code is going to be written. The pseudocode needs to be complete. It describes the entire logic of the algorithm so that implementation becomes a routine mechanical task of translating line by line into source code of the target language. Thus, it must include flow of control. This helps in describing how the system will solve the given problem. Pseudocode does not refer to a precise form of expression. It refers to simple use of standard English. Pseudocode must use a restricted subset of English in such a way that it resembles a good high level programming language. Figure 4.8 shows an example of pseudocode. Let's see. Figure 4.8. If R works is greater than max work R, then display overtime message, else display regular time message. And if example of a pseudocode. Contents of a typical system design specification document. Content. Introduction. Purpose and scope of this document. Full description of the main objectives and scope of the SDS document is specified. Definitions, acronyms, abbreviations and references. Definitions and abbreviations used are narrated in alphabetic order. This section will include technical books and documents related to design issue. It must refer to the SRS as one of the referred books. Oh, what happened? Oh, we are again back. System architecture description. Overview of modules, components of the system and subsystem, structures and relationships. Interrelationships um, and dependencies among various components are described. Here, the use of structure charts can be useful. Detailed descriptions of components. Name of the component, purpose and function, subroutine and constituents of the component, dependencies, processing logic including pseudocode, data element used in the component. Appendices. Test design document. What is test design document? During system development, this document provides the information needed for adequate testing. It also lists approaches, procedures, and standards to ensure that the quality product that meets the requirement of the user is produced. The document is generally uh, supplemented by documents like schedules, assignments, and results. A record of the final result of the testing should be kept externally. This document provides valuable input for the maintenance phase. The following IEEE standards describe the standard practices on software test and documentation. 829 to 1998 IEEE standard for software test documentation. 1008 to 1987 R1993 IEEE standard for software unit testing. 1012 IEEE standard for software verification and validation. The following is the typical content of test design document. Introduction. Purpose. The purpose of the document and its intended audience are clearly stated. Scope. Give an overview of testing process and major phases of the testing process. Specify what is not covered in the scope of the testing, such as supporting or not third party software. Glossary. It gives definition of the technical term used in this document. References. Any references to other external documents stated in this document, including references to related project documents, they usually refer the system requirement specification and the system design specification documents. Overview of document. Describe the contents and organization of the document. Test plan. A test plan is a document that describes the scope, approach, resources, and schedule of intended testing activities. It identifies test items, the features to be tested, the testing task, and the person who will do each task, and any risk that require uh, contingency planning. Contingency planning. Schedules and resources. An overview of the testing schedule in phases along with resources required for testing is specified. Recording of tests. Specify the format to be used to record test results. It should very specifically name the item to be tested, the person who did the testing, reference of the test process slash data, and the results expected by the test. The date tested. If a test fails, the person with the responsibility to correct and retest is also documented. The filled out format would be kept with a specific testing schedule. A database could be used to keep track of testing, reporting test results. A summary of what has been tested successfully and the errors that still exist, which are to be rectified, is specified. Verification testing, unit testing for each unit slash component. There must be a test which will enable tester to know about the accurate functioning of that unit. Integration test is done on modules or subsystems. Validation testing. System testing. This is the top level of integration testing. At this level, requirements are validated as described in the SRS. Acceptance and beta testing. List test plans for acceptance testing or beta testing. During this test, real data is used for testing by the development team. Acceptance testing slash alpha testing or the customer beta testing. It describes how the results of such testing will be reported back and handled by the developers. User manual. The document is complete at the end of the software development process. Different types of user documentation. Users of the system are not of the same category and their requirements vary widely. In order to cater to the need of different class of user, different types of user documentation are required. The following are various categories of manuals. Introductory manual, how to get started with the system. Functional description, describe functionality of the system. Reference manual, details about the system facility. System administrator guide, how to operate and maintain the system. Installation document, how to install the system. The following is the typical content of user manual. Introduction. Purpose. The purpose of this document and its intended audience is stated. If there is more than one intended audience, provide information in this section and direct the reader to the correct sections for his or her interest. Scope of project. Overview the product. Explain who could use the product. Overview the services that it provides. Describe limitation of the system. Describe any restrictions on using or copying the software and any warranties or contractual obligations or disclaimers. Glossary. Define the technical terms used in this document. Do not assume that the reader is expert. References. References to other documents cited anywhere in this document, including references to related project documents. This is usually the only bibliography in the document. Overview of document. The contents and organization of the rest of this document are described. Instructional manual. This section should be divided in a manner that will make it user friendly. System usage. Provide examples of normal usage. Images of the screen dumps are very useful to provide a look and feel of the product. Provide any necessary background information. Online help system is very common for systems today. Information on how to use the online help system, how to access it may be provided here. User reference manual. List of services provides an alphabetical listing of services provided by the system with references to page numbers in this document where the concerned service is described. Error messages and recovery provides an alphabetical list of all error messages generated by the system and how the user can recover from each of these errors. Installation information. Installation information is provided including the operating environment. Maintenance manual. The supplier/developer of the software is sometimes different from the software maintenance agency. In such cases, the cri- uh, criticality criticality of maintenance manual assumes a bigger role. Maintenance manuals provide precise information to keep your product operating at peak performance. Similar to installation manuals, these documents may range from a single sheet to several hundreds of pages. So here we come to the end, and the check your progress answers will be available in the description below, so you can check that out. Till then, keep keep exploring. Bye bye.